Hey, how's it going? Let's talk about using linear models. Hey! Hmm, linear models. Did you know that sometimes it's possible to model data from a real world situation with a linear equation? You can then use that equation to draw conclusions or make predictions about the situation. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. And you can look at a scatter plot and use that to determine how strong of a relationship or correlation there is between the inputs and outputs of the ordered pairs. So you can have a strong relationship, and here you go. Here's how you look for it. The closer the data points fall along a line, the stronger the relationship, and depending on if that line has a positive or negative slope, it's a positive correlation or a negative correlation between the two variables. And I'll kind of explain what a positive and a negative correlation mean and what they look like. Alright, so here is a strong negative correlation. A strong negative correlation means that they're pretty bunched up around, you can imagine a line going through these points. You can imagine a line going through kind of like the middle of those points. You might imagine it a little better than I drew it, but you can imagine it nevertheless. So when the points in the scatter plot are all gathered around a line, that's a strong correlation. If that line's going downhill from left to right, that's a negative correlation. The reason it's a negative correlation is because you could say as x increases, our y values are decreasing. So back here when you have a low x value, you have a high y value. Over here where you have a higher x value, you have a lower y value. So as x increases, the y values are decreasing. That's a negative correlation. What does a weak negative correlation look like? Well, they're not grouped so tightly, but you can still imagine a line kind of going through them that they're kind of grouped around. Okay, and that line's going downhill, but it's a weaker correlation because they're not as tightly grouped around that line. But it's still a negative correlation because as your x values increase, your y values decrease. What does no correlation look like? Yeah, they're just all over the place. As x increases, you don't see a trend happening with your y values. You can't say that when x is low, the points are higher, and then when x is high, the points are lower. They're just kind of the same. No matter what x is, they're just all over the place. All over the place. So here's a weak positive correlation. That's weak, bro. Because they're not as tightly grouped around, but as x increases, y also increases. So as x increases, y also increases. That's a positive correlation. And if they're grouped more tightly around this line that you can imagine, then it's a strong positive correlation. Alright, so we're going to use a scatter plot. Now, here we have a bunch of data. We got the average temperature for the month and average electricity cost for that month. And we're going to see if there's a correlation. So we're going to make a scatter plot. And I'll tell you what, I'm going to show you two cool ways to make scatter plots. Instead of just drawing a graph and then going like, alright, so here's 70, here's 80, and then trying to put your own dots in there. That's lame. We don't want to do that. No, we're going to use technology to make scatter plots. So I'll show you one way. If you have one of the school computers, you might have this calculator on there, but you can get a free TI-84, TI-80 whatever emulator to run on your computer. And you can use that calculator to run scatter plots for you. So what you would do is you would go to, there's this stat button. So click on stat, And then edit is highlighted, so you can hit enter, and then you can edit some lists. And so for list 1, we'll take the inputs. We'll put in 61, 58, 67, and so forth. And once you've got all those values entered, hit the little arrow to go over to L2, and we can enter the values for list 2. 150. I need to enter them so they're corresponding. 61 is the first one, 150. So these two are going to be an ordered pair. And 139. So once you have all your input values on list 1 and all your output values on list 2, then you're going to use this stat plot function here. So you use the second button and then stat plot. And then we're going to use number 1 here, hit enter. If it says off, you can just make sure the cursor's on and hit enter. And then we can select what we want our graph to look like, box and whisker, or this one is a scatter plot. Make sure that our x values are list 1, our y values are list 2. Then we can pick what kind of marks we want our points to look like. I'll just do plus signs. And then color, you can select a color if you want. And then I'm going to click the graph button. And I'm going to say, I don't see anything. And that's true, because if you look at the way this is set up, this is like 0 through 10, 0 through 10, and where are my points? They're like at 60, 150. So my points are way up off the computer screen. So what I need to do is I need to adjust my zoom. I'm going to click zoom, and then I'm going to do 9 where it says zoom stat. And now it will give me where all these points are. And now I can look at that and say, alright, does this have a correlation? Do we have a correlation here? And it looks like a pretty decent, pretty strong, positive correlation. Okay, now I'm going to show you another cool way. If you don't have that calculator, you can use Excel or another spreadsheet software. So it's kind of similar. You can label your columns, and then you put the values in, 61, 58, and so forth. And then when you've got them all in there, I'm going to stretch this over real quick. When you've got them all in there, you're going to highlight the whole chunk, and then do Insert, Scatter Plot, and then it'll ask you to pick which kind, and you'll be like, hey, I like the kind with the dots. And it makes this cool little scatter plot for you. And if you wanted to, it's even pretty cool. It'll even give you like the line. How cool is that? I think it's pretty cool. That's how cool it is. So, either way, you're gonna get this cool little scatter plot, and then you can talk about the correlation. That's a strong positive correlation we got there. Cool. So step 1 is make a scatter plot. We did that. This is what theirs looks like, but I showed you how to make 2 pretty awesome ones. As the temperature increases from like the 60s up to the 80s and 90s, the electricity cost also increases. They're pretty tightly clustered around one line, so there's a strong positive correlation. And that makes sense. When it's hotter, people run the air conditioner more, and the air conditioner uses a lot of electricity. And your bill's going to go way up. Ask your parents about that. Okay, so pause. See if you can figure this little guy out. And then push play when you're ready to see some awesomeness happen in front of you. Alright, so I am going to go right back to that Excel sheet. I'm going to get a new sheet in there, and I'm going to enter some values in here. Let's see. hours, whoa, hours online. And test score. All right, hours online, we got 0, 0, 1, 1, 1.5, 1.75, 2, 2, 3, 4, 4.5, and 5. Test scores, we got 100, 94, 98, 88, 92, 89. And as you're going through, you want to just check and make sure they line up right. 175 and 89, 1.75 and 89. Okay, good. 75, 70, 78, 72, 57, 60. Okay, now that I have taken the information from that chart, I can make it go away. Don't need to look at that now. And then I'm going to insert charts, scatter plot. And it looks like what we've got here is they seem to be clustered around a line, but that line is going down. So that is kind of a negative correlation. You might even say pretty strong negative correlation. Okay, so we made our scatter plot. We described the correlation as a strong negative correlation. Now, using the graph from problem 1, whoosh, how much would you expect to pay for electricity if the average temperature was 70 degrees Fahrenheit? Well, what we would do is we would imagine a line going through here. Okay, let's imagine that together. Whoa, you got a good imagination. So, looks like around at 70 degrees, follow that up, and we're right around here somewhere. So that's, you know, see, this would be 160, so that'd be like 170. So we're talking like 170 to $180. About. So we've been using these little lines, and these little lines are called trend lines. A trend line is a line that approximates the relationship between the variables of a scatter plot. You can use a trend line to make predictions from the data. In a previous lesson, you learned how to use 2 points to write the equation of a line. You're going to do that some more. Alright, here is a problem. The table shows the median. The table shows the median home prices in Florida. What is the equation of a trend line that models a relationship between the time and the home prices? So we'll say the time is our x value and the home prices is our y value. Use this equation to predict the median home price in 2020. So when you have perfect vision. Just kidding. So we know 7 data points. 1, 2, 3, 4, 5, 6, 7 data points. We need the equation of a trend line. What we can do is plot the given points, find a trend line, and write the equation using 2 of those points. Alright, so let's do it. So let's let x equals 0, so because we don't want our graph to start at 0 and then go all the way to 2000. So let's let x equals 0 represent 1940. So this would be 0, and then 10 years later it would be 10, and then 10 years later than that, x would be 20, 10 years later it would be 30, then 40, or then 50, then 60. So we'll sketch a trend line. We'll make a scatter plot and sketch a trend line. So pretend you did that in that program, I can't remember its name, Excel. There you go, Excel. Pretend you did that in Excel. So there, we sketched it. Now we're going to choose 2 points on the trend line. We're going to take 10, 40,000. So that's this point right here. This one's actually on the line. It's not the actual data point, because the actual data point is 10, 40,100. So we're going to take this point on this trend line, 10, 40,000, and then 55, and what is this? 110,000. Yeah, so this would be 110,000 right here. So there you go. 2 points that are on the line. And we're going to use slope-intercept form to write an equation for the line. The intercept is apparently 24,440. How did they get that? Let's investigate. Okay, so we got 2 points, so we can use those 2 points to find the slope, which should end up being this, right? So y2 minus y1, 110,000 minus 40,000 divided by x2 minus x1, so 55 minus 10. So that is 70,000 over 45, which is, let me do this in my head, I don't know, 1,555.5 repeating, which we can round to 1,556. So that was our slope. Now you can use one of these points and the slope in point-slope form. So let's do y minus y1, which is 40,000, equals m, which is 1556, times x minus x1, 10. Distributive property, y minus 40,000 equals 1,556x minus 15,560. Then when I add 40,000 to both sides, I get y equals 1,556x plus 24,440. So that's where they got this y-intercept. So there's a lot of work in between here and here, and it's all right there. Okay, so what's next? Let's use this equation to predict the median home price in 2020. So in 2020, this is going to be 20 years after this one, so that'll be 80, so x equals 80. So we're going to plug in 80 in for x, and when you math it all up, you're going to get 148,920. So based on this trend line, the median home price in the year 2020 will be around $149,000. And that must be, I don't know, in the middle of nowhere in Texas. I don't know, because houses are not that cheap. Okay. Oh, it was in Florida. Must be in somewhere not nice in Florida, because that is not an expensive house. Is there places in Florida where you can buy a junky house for 150 grand? I don't know. Okay, so let's see if you got it. Let's see if you got it. Go ahead and pause and see if you got it. And then push play when you're ready to see if you really do got it. Alright, so I am going to crack open Excel here. Get a new sheet. And I'm going to enter me some values. And I'm going to say, let's let x equal 0. I'm going to get a better color to write with. Let's say x equals 0 at 1940. So 10, 20, 30, 40, 50, 60, and so on. So, let's see. Call this time, and I'll call this price, and I'll start entering stuff. 0, 10, 20, 30, 40, 50, 60. Price was 36,700. Whoops. 36,700. 57,900. 74,400. 88,700. 167,300. 249,800. Something started happening here. And in the year 2000, 211,500. Prices went back down a little bit. Okay, now let's get us a scatter plot. Insert charts, scatter plot. Okay, why aren't we moving? There we go. Okay, I'm gonna pick this one that puts a, let's see what this one does. Ooh, gives me a function for the line. That's a little bit cool. Okay. So let's pick a couple of points on this line. Let's see if we can find a couple of points on this line. Alright, hear about this. This point right here is 20, comma, see, 50,000, 60,000, 70,000, 80,000, 90,000. So 20, comma, 90,000. I'll make a note of that. 20, comma, 90,000. See, right here is another point. That's like on some grid lines here. So straight down, we're like one line short of 60. So in between 40 and 60, there's 20, and there's 5 partitions, so each one of these is worth 4. So 44, 48, 52, 56. So 56 is the x value, and then the y value is 200,000, 210, 220,000. So 56, comma, 220,000. 56, comma, 220,000. Alright, so I'm going to use my magical slope formula. 220,000 minus 90,000 divided by 56 minus 20. So that's 130,000 divided by 36. 130 grand divided by 36 is 3611.1. So let's just round that to 3611. Alright, so my slope is 3,611. So slope intercept, point slope form, is y minus y1, 90 gur, equals m, 3611, times x minus x1, which is 20. Distribute, I got y minus 90 large equals 3,611x minus 72,220. So now I'm going to add 90,000 to both sides. And I get y equals 3,611x plus 90,000 minus 72,220, 17,780. Alright, so there is my equation that models the relationship between the time, x, and the home prices. Cool, huh? Tofu sculpture is your secret phrase. How do you like that? The trend line that gives the most accurate model of the related data is called the line of best fit. So imagine you had a bunch of data, and you could say, well, this is a trend line, this is a trend line, that's a trend line, this is a trend line. Which one's the best? Well, there is a way to find the best. And the name of that best line is called the line of best fit. One method for finding the line of best fit is linear regression. You can use the linreg function on your graphing calculator to find the line of best fit. Also, there's this thing called the correlation coefficient, R, that indicates how strong the correlation is. If R is close to 1 or negative 1, meaning that the absolute value of R is close to 1, the more closely the data resembles the line. So the closer R is to 1 or negative 1, the stronger the correlation. Alright, so let's check this out. You research some milk. Good job. Here's the data. What is the equation of the line of best fit? How accurate is your line of best fit? So you're going to use the stat feature to enter the data in your graphing calculator. I'll show you how to do this on Excel also. So use the stat feature to enter the data in your graphing calculator. Enter the x values in L1, the y values in L2, and then let's let 1997 equal year 0. So this would be 1, 2, 3, 4, 5, 7, 9er, 11, and so forth. Then you're going to use the linreg button, which I can help you find, to find the line of best fit. And so it says y equals ax plus b. It figures out the slope for you. It figures out the y-intercept for you. And then it finds r squared, and then they take the square root to give you r. Look how r is pretty close to 1, so this is a pretty good fit. So now I'm going to show you how to do that with Excel. So I'm going to label this column year, and then I'm going to label this column cost. And I'm going to put in my values, 1, 3, 5, 7, 9, 11. And in year 1 it was 2.65, 2.89er, 3.00, 3.01, 3.20, and 3.77. Highlight them bad boys. Insert, scatter plot. And then right up here, this one that has the little f of x on it, that's the one that'll give you the function. So look what it gives you. It gives you y equals 0.0934, which is pretty close to what we got on the calculator. And then the y-intercept is 2.5 something something. It gives you r squared. So we would need to grab a calculator and do 0.8 4, 5, 7, and then take the square root to get r. So r is 0.9196, which is close to 1, which tells you that's a strong correlation. Okay, so you want to see how to do it on this calculator? I'll just show you how to find the lin reg if this is what you're using. So the first thing you have to do is go to stat, put in your list, 1, 3, 5, 7, 9, 11. And then 2.65, 2.89, 3.00, 3.01, 3.20, 3.77. And now once your lists are in there, then you're going to hit stat again, and then you're going to move the cursor over to calc, and then linreg ax plus b, and hit enter. And x list is L1. Calculate. Okay, so this one just gives you A and B. This one doesn't give you the R. So if your calculator is not showing you the correlation coefficient R, here's what you do. Click on Mode. Go down to Stat Diagnostics. Switch it over to On. Now you go back to Stat and run the linear regression. Calculate. And now it does give you the correlation coefficient, which is close to 1, which is strong. I don't know. The Excel seems a little easier to me, but if this is what you got, this is what you got. So based on your linear model, how much would you expect to pay for a gallon of whole milk in 2020? Well, here's your line of best fit. So in 2020, that's what year it's going to be. I mean, that's what the time is going to be. Let's take a look at that. In 2020, it would be, let's see, in 2010, it would be 2 more, so that'd be 13. So then in 2020, it would be 10 more than that, which is 23. All right, fair enough. Okay, so we use the line of best fit. It'll be 23 years later, so we put a 23 in for x, and then we math it up, and it would be 4.6. So $4.60 a gallon for whole milk. It's more expensive than gas, but hey. I think they kind of go along together, don't they? Gas prices and milk prices. It's too bad your car can't run on milk. Okay, so why don't you try number 3, see if you got it. Dude, you got it? Okay, so I'm going to use Excel because I think it's easier. And I'm going to say that 1998 is 0. So the years will be 0, and then 2, 4, 6, 8. Let's see, this was 0, 2, 4, 6, 8, 10. And then my costuses, 2.57, 2.83, 2.93, 2.93, 3.10, 3.71. And now I am going to run a linear regression by doing insert, scatter, and then selecting where to go. So in here under chart tools, if you click on design, you can then select the one with the function guy on it. And I get y equals copy that. I don't know if I can copy and paste into this. So I got my line of best fit is y equals 0.09x plus 2.56. And my r is going to be the square root of 0.806, which is 0.898. Which is pretty close to 1, so that's a pretty good dealio. Alright, so now I need to figure it out for the year 2025. Okay, so 2025. Well, let's see. 2010. See, this was 0, 2, 4, 6, 8, 10, 12. So 2020 is going to be 10 more than that, so that'd be 22. And then 2025 would be 5 more than that, so 27. So I need to plug in x equals 27. Y equals 0.09 times 27 plus 2.56. And now I'm going to crunch it up. 0.09 times 27 is 2.43 plus 2.56 is 4.99er. So we could expect to pay $4.99 for a gallon of milk. Good thing I'm vegan. Woo! Alright, get to work, y'all. See you later.